Okay, so in this video now we will be looking at quadrilaterals. Now in this particular video, it's not going to be too long because just for the simple fact that, as you know, with quadrilaterals, the only thing you really need to know is obviously the properties. And I'm sure you've looked through your handout, and in your handout it's still the same. It's just looking at the properties and just knowing how many sides they have, are they parallel, and so on and so forth. So yes, we have quadrilateral family, and in the quadrilateral family we have the trapeziums, we have a kite, and then we have a parallelogram, we have a rhombus, a square, and a rectangle, right? But now let's look at the properties of these quadrilaterals. Now, quadrilateral basically is anything that has four closed sides, and the interior angles all add up to 360. Now, meaning that if we take the angle that is there and there and there, when we add all these four angles together, they should give us 360 degrees, right? And then we also have what we call a trapezium. Now, a trapezium is only one pair opposite sides are parallel and there's no lines of symmetry. So in this case, then a trapezium has only one pair of opposite sides which are parallel. So meaning one pair of opposite sides that are parallel and no lines of symmetry, right? And what do they mean by no lines of symmetry? If I could just explain. Basically, if you had to put in a symmetry line in the middle here, if you try to fold this onto the other side, they'll never fold onto each other. So even if you could try and put it across like that, or any other way, you could never actually fold a trapezium um, uh, um, into identical parts, right? You can't ever fold it one onto the other, right? And then we have a parallelogram. And so with a parallelogram, both pair of opposite sides are parallel. Both pair of opposite sides are parallel. So basically, any all sides are just any side. This side is parallel to that side. That side is parallel to that side. Both pairs of opposite sides are equal in length. Basically, this one and that one is equal in length as much as that one and that one are equal in length. And then both pairs of opposite interior angles are equal, right? And so the opposite angles are equal as well. And then there's no lines of symmetry as well. So again, as I explained about no lines of symmetry, what that means. Okay. And then we have a rectangle. So with the rectangle, if you can see, we have two lines of symmetry. All interior angles, all interior angles equals to 90, meaning all everywhere at the corners it's 90 degrees, right? It's all 90 degrees, and then both pairs of opposite sides are equal in length, and also you find that they are parallel as well, right? Opposite sides are parallel. Then we have the square. So a square again, this is the most common. Both pairs of opposite sides are parallel. All sides are equal to each other, and all interior angles equal to 90 degrees. And then with the rhombus as well, both pairs of opposite sides are parallel. All sides equal in length. Both pairs of opposite interior angles are equal in length, and two lines of symmetry. And then we have a kite, and basically with the kites it says these are two parallel adjacent sides are equal in length. One pair of opposite angles are equal to each other, where the short side meets the longer side, one line of symmetry. And then we have the trapezium again, where really with the properties of diagonals, there's nothing special with the diagonals of a trapezium. With a parallelogram, the diagonals bisect, and bisect basically means what? It means that it divide into two equal sections, and then the diagonals are not equal in length, right? They're not equal in length. The parallelogram, oh, they are not equal in length. Yeah, but the opposite sides, this is equals to that side, but that side is equals to that side, right? So the opposite sides are equal to each other because, as they said, they bisect. And then with the rectangles, the diagonals bisect each other and is equal in length. So all of them are equal in length and they bisect each other, the diagonals. And the diagonals, in this case, then the diagonals are perpendicular and equal in length, and the interior corners, the diagonals bisect the interior corners as well, right? So the interior corners, this was 90 degrees, remember? So the half of 90 degrees is 45 and 45, 45, 45, 45. So they bisected that angle, but also when they cross each other, where they intersect, they have the 90 degrees, and also they bisect each other in such a way that the lengths are the same for all four diagonals. Then we have the rhombus and kite, and so the diagonals bisect each other perpendicularly, and the diagonals bisect the interior opposite corner angles, and then the long diagonal bisects the short diagonal perpendicularly. The diagonals bisect the interior opposite corner angles only where the adjacent sides meet. So basically that is it for quadrilaterals. As I said, this was going to be a very short one. So other than that, I really hope this is helpful, and I'll see you soon.